Okay, today we're going to be talking about area, which is the space enclosed within a shape. We're going to talk a little bit about some formulas. We're going to talk a little bit about formulas, and we're going to be talking about, and we're also going to talk about some strategies. Now, when it comes to area, there's a lot of different formulas, but a lot of them, one of the things you're going to note that's fairly common is multiplying two you're going to end up multiplying at least two different measurements. That's one of the reasons why your units are squared units. So you're going to end up with inches times inches, centimeters times centimeters, meters times meters. That's one of the reasons why you've got square units. Let's go over let's go over some of our different shapes. And as always, it's a good idea to start with one of our most basic shapes, the rectangle. And for a rectangle, once again, we've got length and width. And your area is just going to be literally the length times the width. Well, we're going to introduce another shape here, and that happens to be a parallelogram. And a parallelogram has two sets of parallel sides. Now, as tempting as it might be to include this kind of different leg, we're going to be thinking about this in terms of base and height. So you're gonna get another sort of internal measurement here, and you're gonna discover that the area of a parallelogram, and this is a fairly common thing, is gonna be the base times the height. Now, part of this is relatively easy to see if you were to do something like, oh, I don't know, if you were to cut this particular, cut that little piece off and then tack it on right here, you would be right back to a rectangle. So that's one of the reasons why the area of a parallelogram looks a lot like the area of a rectangle. Anyway, next, let's talk about a triangle. And triangles, you're also going to be given a base and a height. The area here is going to be 1/2 of the base times the height. Now, when you're thinking about this, I always like to say, if you want to know kind of where that comes from, think about this. If I were to take a parallelogram, there's my height, there's that base, and I were to cut that in half, it's literally, this is, this is literally half of a parallelogram. That's where that formula comes from. So if you ever have trouble remembering that, realize that's a lot of where those things are coming from. Now the last of our shapes here is our circle. And with a circle, once again, we're going to be looking at the radius. When it comes to circles, though, your area is going to be equal to pi times r squared. So that's going to be the radius times the radius. So the one way that it's easy for me to differentiate between the area of a circle and the circumference of a circle is I've got a radius times itself. That gets us right back to those square units. Okay, let's talk a little bit about strategy. Now, most of what you're going to find when you are figuring out your areas is just identifying the pieces. And for that, you might want to draw a picture and just identify what is the base equal to, what is the height equal to, or what is the length and the width, things along those lines. One of the other common things that you're going to run into, though, are composite shapes. Shapes that are literally just things kind of tacked together. Now, one of the things that you can do with something like this, so say I've got something like this. I could have a basketball court, or maybe I could have something where I've got a triangle tacked onto the end of something, and then I've got another, and then I've got a semicircle. What you're going to do, you could say, okay, I've got this side here, I've got this height here. I might be given a base for what this is. What you're going to do is you're going to split this up into different shapes. And you might need to modify things. Like, for example, when I look at this, I see I've got half of a circle, a semicircle. I have a rectangle. And I also have a triangle. Just realized I'm using both red and green, and I don't usually like to do that. For anybody who might be colorblind, my apologies about that. These are different colors. But with that, we're still going to be able to figure this out. Now, I'm going to actually work from the middle out because a rectangle is by far the easiest shape we have. And in this case, you know, the area of a rectangle is, say, the length times the width. In this case, I've got one side and a height, so I would just use those. The triangle here is, of course, 1/2 of the base times the height, and my circle is, well, the area of a circle is, of course, pi times that radius squared. But then I would be taking only half of it in this case. One thing that you're probably going to need to do is you would need to figure out what that radius is, in which case your radius is going to be equal to literally half of, in this case, the height is the diameter. Or, so I could say, so when you're doing that, you'd need to do some figuring to figure out what you would do there. But you just break this up into 3 different pieces, and then from there, calculations are relatively simple. Then we've got, now aside from composite shapes, and by the way, if you need to pause and take notes, by all means do so. But beyond composite shapes, we've also got things like perimeter shapes, or you might think of it as negative space. Say you've got like I'll put this as negative space. This would be like an area around something. And with that, what you can do is you can think of this as a large area subtracting a small area. And a fairly common one is, say, like the path around a swimming pool, something along those lines, where you're looking for, you might be given what these dimensions are, and then you might be told that you've got some other distance, some sort of equidistant thing all the way around a shape. Okay, when you're doing that, if you're only looking for part of your of this, if you're only looking for like this area, well, that's still relatively easy to do. You're going to have a first length, you're going to have a length and a width, sort of your, maybe I'll put this as 0, or so that's sort of an outside length and an outside width, and an inside length and an inside width. So what you'll do is you'll find the area outside and then subtract away the area inside. So it's going to be basically on this one, it's going to be the large area minus the small area. And it doesn't have to be rectangles. I've seen this done with squares and circles and triangles, all sorts of things. So this, our large area would be, in this case, length times width, and it's going to be these outer ones. And I would subtract away my inside length, or my inside area, which is length times width again. And this is going to be my shaded area. Alrighty, hopefully this gives you some ideas on how to find areas, and we'll see you in the next video.